Hello everybody. Today we will be discussing the chapter 1 in this video, the introduction to personal computer hardware. So I'm your instructor trainer for today, and we will be starting with the personal computer and the components that we will be evaluating. So the important part here in this particular chapter are the familiarizations of different components and some safety precautions on handling computer devices and the other components. So let's start. So in this chapter, we do have three particular sections or four particular sections that starts with the personal computer. So it will explain how to keep the personal computer components safe. Safety first, okay, are the first topic of this chapter. It also explains the electrical and the electrostatic discharge safety. Then on section 2, we have the PC components, which explains the features and functionalities of our computer components, describe the cases and the power supplies, describe the very important or the largest circuit board in our computer system or our desktop PCs, which is the motherboard. The brain of the computer will be also described in terms of its specifications, or what we call the central processing unit. We will also explain the different types of memory, adapter cards, expansion slots, removable disks, okay, and our internal hard disk drives. Also, we will be discussing storage in terms of optical, the different ports, cables, adapters, input devices, and output devices. And on to the last part of this one, which is the assembly disassembly. So I will not be able to put it here in the video, but we do have one particular video that will um, demonstrate the actual disassembly of the PC. Okay, so let's start with the first section of your chapter 1, which is the personal computer. So I advise for all of our candidates or all of our students to always watch the video. There's a lot of videos in the IT Essential course. So, but we will not going to watch it from this particular recording. So I advise you to watch the recording and watch the video that is present in your curriculum. Okay? So in the first part, in terms of the video, it's just explain what is a computer, and we all know what is a particular computer. So a computer has an input, output devices, and several internal components. So we do have now a different varieties of desktop computers or microcomputers when we repair it on early 90s. So they call it desktop. Okay, so let's go with the electrical safety first. So electrical devices have a certain power requirements. So just like your AC adapters, which are being used in our laptops, and they are having some charges or voltages. So exchanging adapters with different voltages, okay, might damage your laptop devices or any other devices that uses AC adapters. Okay, so remember, so later in later chapters, in chapter 3, we will be learning the basic electricity. So there we can differentiate, okay, what is the difference between an AC adapter and a DC volts adapters. So also our printer, okay, has a parts that contains high voltage. So in our for our safety, we need to check the printer manual for the locations of those high voltages. So most parts in terms of the printers are the main print head. Okay, so if you're having a inkjet, okay, for the laser printer, so mostly of the drum circuitry or the drum okay, part in terms of the lasers are the one with the higher voltages. So if you see the symbol, okay, the triangle symbol like this, so it means that, okay, safety precautions must be, okay, identified. Okay, so that's very very important in terms of safety precautions. Okay, so follow your electrical safety guidelines to prevent electrical fires, injuries, and fatalities in terms of the safety of your um, computers and to yourself also. So also in handling our computer, it is very important to know what they call the ESD, or the electrostatic discharge. Okay, so this can occur when there is a buildup of an electricity charge that exists on your surface, which comes on a contact with another with a different charge. So, for example, while we are walking, okay, we certainly absorb some what they call free electrons. So once those free electrons build up to your body, okay, so when you hold a certain metal, so it will create particular charge. But in terms of having static electricity, so it needs 3,000 volts of static electricity to build up before a person can feel the ESD. So that is the part of having a ESD. And imagine when you have the 3,000 volts and you try to hold some electronic components, especially components from our desktop PC, so you can transfer and damage some of the sensitive components inside your computer. So, we need to follow several recommendations to prevent ESD damage. So, first, we need to keep all components in an anti-static bags, okay, until you are ready to install them. Use ground mats or workbenches, okay. We will be demonstrating some of those when we reach the assembly disassembly. Use grounded floor mats in the work area, especially if you're going to conduct disassembly and assembly of your computer components. So it's much better to have a grounded floor mats. And use anti-static wrist straps. So I'll be demonstrating also and showing to you what are the different example of anti-static wrist straps. Okay, before you able to remove any component of your desktop PC, so you need to make sure that you're using a what they call the anti-static wrist strap. Okay, so and also for electrical safety, you need to make sure that your computer is power off. Okay, remove the adapter or the AC power adapter from the outlet before you're going to conduct assembly disassembly. Okay, so those are safety precautions first, okay, that we need to adapt in terms of the ASD and the voltages or electrical voltages. So let's go with the other section, which is the chapter 1.2. So these are quite long in terms of discussing the different PC components. So the first one that we need to describe is the cases. Okay, the cases houses the internal components of your computer or desktop computer. So it houses the power supply, our motherboard, our CPU, and our memory, as well as the secondary drives, you call disk drives and other adapters. So we do have different types of form factor. When I said form factor, this is the physical design or looks of the case. So common desktop computers has the older one, way back 80s and 90s, we do have the horizontal case. Okay? So horizontal case somewhat, okay? You see that's why it calls desktop. So you will just put it under the top of the this. Okay, so that's what we call horizontal case. And then we do have the full size tower. Okay, so wherein your computer is having its stand into a vertical. We also have the compact tower. Compact tower are quite small, okay, smaller than the full size tower, and it's compact. Okay, and nowadays we do have the all-in-one, wherein you will just see a monitor and a keyboard and a mouse. Okay, wherein your internal components also embedded already to your monitor, okay, or to the screen. So one of the most important part of our PC component is the power supplies. So computer use power supply to convert our voltage from our outlet, we call it alternating current power, okay, into a lower voltage called the direct current power, okay, or the direct current. So if you're going to compare, okay, for those who doesn't have backgrounds in electricity or in electronics, so most of the AC power are those with our 200 to 240 volts. Mostly these are the voltages that we can see in our wall outlets. And then those DC voltages, okay, are the voltages that we can see from our batteries. So, for example, we do have 1.5 volts, okay? Charger of our mobile phone is around 5 volts, okay? So, if you're going to use some motors and those things, they use 12 volts, okay? So, those are our DC power, okay? And most, okay, part in terms of the comparison also of the DC and the AC is this one is having polarity. So you need to be guided with where is the positive and where is the negative part of your DC voltages. For your AC voltages, so this one is having a continuous pulse. Okay, in terms of the wavelength of those things. So let's go back to your power supply. So your power supply also has different form factor or the physical design of the power supply. So the old one is what we call the AT, which is the advanced technology, okay, which is the original power supply for legacy computers. So during 1980s, okay, up to 90s, we are using the advanced technology or AT size. And okay, as the versions goes, so we do have the AT advanced technology and they extended it. So that's why they put X, okay, on this abbreviation. So this is the updated version of AT. So it comes late 90s going to year earlier 2000. Okay, and most common right now is what we call the ATX 12 volts. Okay, or ATX 12. So the ATX 12 is nowadays the most common power supply on the market today. And for those who are using high-end desktop or servers or what they call workstation, so they're using an EPS 12 volts or EPS 12, okay, which is one of the common in terms of the high-end setup or servers. Okay, so those are the different um, form factors of our power supply. And we do have the different types of connectors. Okay? So, power supply has different connectors. So, let me show it to you our curriculum. Okay? So, the first one is the 20 pins and 24 pins. So, you will see here, this part is 20 pins if you're going to count all of this particular pin plus 4, so it can be joined. So there are some motherboards later that only needs 20 pins. There are also motherboards that needs 24 pins. So that's why it calls 20 pin or 24 pin slotted connector. Okay, mostly being used for motherboards. Also, we have the SATA, okay, or serial ATA. So this one is being used for our disk drives, okay, hard disk drives, okay. So this is somewhat a thinner type of Molex. Okay, Molex is also being used before in the old hard disk drives or old magnetic drives and optical drives. Okay, so this is what we call the Molex. And nowadays we are no longer using this one. We have the bird key connector. This is being used on our floppy drives or legacy floppy drives. Okay, so nowadays we are no longer using this one, but it's a part of the power supply connectors. And also we do have the 4-pin to 8-pin auxiliary power connectors. Okay, so the 8-pin to 8-pin auxiliary power connectors has particular two rows like this. Okay, and supplies power on the different area of your motherboard. So there are some parts of the motherboard that needs supplies. Okay, so they are being connected. Auxiliary power connectors is also the same shapes in the main power connector, but quite little bit smaller. Okay, we also have the 6 to 8 pins PCIe power connector. So this has two rows also of 3 to 4 pins. Okay, so it can either have 3 or 4 pins. Okay, supplies power to some internal components. Okay, so those are the different connectors. Okay, aside from the connectors, we also need to understand, okay, the different voltage that our power supply uses. So most common voltage supplied are the 3 volts, okay, 5 volts, and 12 volts. Well, of course, as I told you a while ago, when referred to the 3 volts, 5 volts, and 12 volts, those are the DC, okay, direct current voltages. And I told you also that if there is DC, okay, there is a polarity which is a positive or a negative. Okay, so if we have 3.3 volts, there will be also negative 3.3 volts. So if we have positive 5 volts, there will be also a negative 5 volts. And if there is a 12 volts, you will also see a color which is a negative 12 volts. So the 3.3 volts and 5 volt supplies are typically used on some digital circuitry. Okay, so while 12 volts are being used to run motors, so just like our hard disk drive, okay, so it can be driven using a 12 volts supply. Okay, so our power supply can also be single rail or dual rail or multi-rail. So what are those multi-rails? When I said rails, this is the printed circuit board or the PCB inside, okay, wherein the power supply to which the external cable are particular connected. So a computer can tolerate slight fluctuations in the power, but significant deviations can cause a power supply to fail. So that is why there are some, okay, users that they need to check whether how I'm going to use single trail or dual trail or a multi trail. Okay, so let's explain those one. Okay, so another explanations in terms of technicality of rails. Okay, rails are the channels through which the power supply feeds electricity to all of the components of our computer. So in our computer, generally we just talk about 12 volts rail. Okay, since these have a bigger impact, so a computer, but a bigger impact in the computer, but power supplies have also rails in terms of 3.3 and 5 volts channel. So each rail of the power supply has a overcurrent protections or the OCP, and it is limited on one OCP per rail. Okay, so this way, okay, if our power supply relies on 12 volts, let's say 12 volts, so it will have one over current protection. Okay, so that is why if I only have one 12 volts, and all of those is being split. Okay, so somewhat one, okay, 12 volts, and you can split it into many, okay, connectors. So we might be having a overloading when we connect too much, okay, components in one particular single trail. So what we're doing in terms of some setup in terms of the power supply, okay, instead of only having single trail of 12 volts, so they added another trail, okay, of 12 volts connector. As you can see here in this type of power supply, when you buy a power supply, this is very important. The label part of, okay, the power supply, because this one will give you how many ampere rating do we have. So later in chapter 3 we will be discussing basic electricity, and I will explain it to you how this, okay, current rating, we call it current rating, okay, can be used, okay, to compute on how many components I can inject into my desktop computer. Okay, so here you will see multiple trails of, or rails, sorry, rails of your 12 volt supply. So I have 1, 2, 3, 4, 5, okay, 6 different rails of 12 volts. Okay, so that is how you're going to explain what are those rails. Modern power supply is having this removable, okay, connectors. So we're in, you will just plug some cables, okay. So here this is one particular rail, okay, of connectors. Then here can be separated on another rail. So mostly this one is being used on some of the gaming PC or high-end PC, okay, because one gaming PC will be having multiple GPU or graphical cards, so they will be needing separate power supply connector. So we will be seeing that one as we goes and on an advanced setup of our computer. Okay. So speaking of the power supply, the main component that being supplied by our power supply is the motherboard. Okay, so this particular motherboard is the main backbone of the entire particular component of our CPU. So it is a printed circuit board, or we call it a PCB, one of the largest PCB in our computer system, which contains the different buses, electrical paths. So these lines here are known as the electrical paths, okay, that interconnects different particular components. So these components may be soldered directly, or during manufacturing, it will be designed, these particular parts, okay, via, okay, automations. Okay, that's why this one is very very tiny. Okay, when you look into the circuitry of PCB boards of a motherboard. So these components may be soldered directly, okay, to the motherboard, or added using sockets or expansion slots, or that's why we have different port connectors. So our motherboard handles majority of the major components, okay, of our PC. Okay, it starts with the very important component, which is the central processing unit. Also, we do have the RAM, okay, the expansion slot. So these are the example of the different expansion slots. Okay, so this is the CPU. Okay, so these are the RAM slots. Okay, and chipsets. So chipsets are used to handle different functionalities in our motherboard. So this consists of integrated circuitry on the motherboard and control how your system hardware interacts with your central processing unit. Okay, so it is also established how much memory can be added, okay, to a certain motherboard in terms of the types of connectors or types of board connectors. Okay, we also have the basic input-output system. Okay, in the older days and nowadays we still using the BIOS or the basic input-output system. Okay, but the updated one of the BIOS is what we call the Unified Extendable Firmware Interface or UFI. Okay, on most of the updated um, part of the computers nowadays. Okay, also it handles the serial ATA. Okay, so here we do have the BIOS chips. Okay, and for serial ATA, or we call it SATA. Okay, where's the SATA here? So there is no, I think it's on this side. Okay, but it doesn't show. But later I will be showing you a motherboard which we can see a particular SATA and an internal USB connectors. Okay, so those are the different parts of our motherboard. Okay, so the board a while ago cannot be shown our SATA, so this is what we call the SATA connector. Okay, used for SATA hard disk drives or SATA optical drives. Then these are the IDE, okay, or integrated drive electronics. This is an older version. Okay, before SATA came, so we're just using a IDE. So later we will be showing to you the type of cable that an IDE has. Okay, compare it nowadays with the particular SATA cable. And we do have the internal USB. Okay, so this is an example of an internal USB. So when you create a connector, so you can extend, okay, or you can add one more USB towards to your computer system. Okay, and one important part in terms of the motherboard is the motherboard chipsets. So this one, as I told you, it consists of integrated circuitry, okay, that controls how the system hardware interacts from one component to another. Very special, the interactions of your central processing unit towards to your motherboard. So our motherboard, okay, is divided into two particular main chipsets, which is first the North Bridge. Okay, so when you said North Bridge, this one controls the high-speed access of your physical memory RAM and your video card. That's what we call the North Bridge. So you will see here familiarization of the board. So once you see the RAM, okay, then you see the graphics card adapters. So most probably that location is called the North Bridge. Okay, so once you see the connector of our hard disk drive, the connector of your USB, or the connector of your not connector, the BIOS or the UFI chips, then most probably you are locating our South Bridge. Okay, so this is somewhat another illustration. So most we have this input output or super input outputs as your serial port, parallel port, floppy disk drive, keyboard, and mouse. So those parts interconnects to your south. Okay, also we have the slots, okay, expansion slots as your PCI slots, and your BIOS, okay, controls towards to your south bridge. Also we have the memory slots, the CPU, and the graphics slots, okay, will be controlled by the North Bridge. So let's see one particular board example. Okay, here. So if you see this expansion slots, okay, so most probably this is the video, okay, and this is the RAM slots. Okay, so a while ago when we said The RAM and the CPU, that's part in terms of your north bridge. So here are the hard disk connections, or we call it the SATA connectors. Okay, so plus here there are some USB and some other components that will be connected, some at this pin and this one. Okay, so plus this is the PCI. So when we cut that one, okay, so this is your north bridge chipset and this is my south bridge chipset. So that's how you're going to check and evaluate your motherboard chipsets design. Okay, so motherboard form factors. So if the power supply has a form factor, your board also must be having a form factor. Okay, so or the physical design of size and shape of your motherboard. So there are three common motherboards form factor. So it started with the Advanced Technology Extended, or we call it ATX. Then we also have the Micro ATX and the ITX, which is currently the standard nowadays. Okay, so there are two. If you see very small compact computers or compact desktop, so those are having mini ITX. Okay, if you're having a standard connection, so that will be what they call the ITX. So they will differ from the size of the board, the dimension of the board. Okay, so I want to focus on this two because this is the currently types of form factor of the motherboard nowadays. Okay, so popular desktop and small form factor computers might be having some micro ATX. Okay, I don't know if we still have micro ATX, but most probably these are the old computers nowadays. So we have the ITX and the mini ITX. So later we will be discussing how to choose a motherboard, compatibility with the power supply, compatibility with your CPU, so that when you want to purchase and assemble your own computer, so you will be able to evaluate how you're going to combine them together. Okay, so the brain of the computer, which is the CPU. So this is what we call the central processing unit, okay, which is responsible in the interpreting and executing commands in terms of your computer system. So CPU is a small microchips that resides within the CPU packages. Okay, CPU sockets is a connection between your motherboard and to your processor. So here is an example. Okay, the picture here is the example of a CPU socket, and this is the CPU. Okay, when you talk about, as you see here, there are some pins, okay, towards to your CPU. So that's what we call, okay, the pin grid array. So the pins are on the underside of the processor itself. So this is the processor. Now, if the pin, okay, if the pin is inside the socket of your motherboard, okay, and your processor doesn't have any pin like this, then it will be called as the LGA, or the LAN grid array. So that is the LGA. Okay, so a processor and some other GPU, or graphical processing unit, needs a cooling system, because most of our processors emits heats. Okay, so it emits high temperature. So computer components perform, we need to perform while we are using our computer, it needs to be cooled. Okay, so computer are kept to cool using active and passive cooling solution. Okay, so active solutions requires power, while passive solutions do not require that particular power. So passive solutions for cooling usually involves reducing the speed at which the component is operating or adding heat sink towards to the computer chip. So most of our CPU is having, okay, a heat sink like this. Okay, so a case fan is considered as active because we need a supply to make the fan rolling, okay, or spinning. So that's the difference between two different types of cooling system. So we've learned with the power supply, we've learned with the motherboard, and we've learned with our CPU. So now we need to understand the primary type of memory. So here it's just describe the types of memory, but okay, in the old times we're using the types of the memory as the primary memory. Okay, so later you will hear from me the what they call secondary type of memory. So why there is primary, why there is a secondary. Okay, so let me explain some computer organization or computer system organization. So if this is our CPU, okay, our CPU talks directly with the main memory system or the primary memory system called the RAM, okay, and the ROM. So I cannot write on this one. So okay, so the other one is RAM and the other one is ROM. So this CPU directly communicate with our central processing unit together with the three types of, okay, buses. So we have the data bus, we have the control bus, and we have the address bus. Okay, so at the end of this one, the connectivity is the third part of the our component, which is the input output system. One reason why, okay, these two types of memory, the ROM and the RAM, is being called as the primary memory. Okay, so later I'll be discussing how about the secondary. If we have primary, then we will be having secondary type of memory. So let's go first with the types of memory. So all memory chips stored in data in a form of bytes. Okay, a bytes basic unit of our information. Okay, which is bit. So 8-bit is equivalent to an 8-byte stored either a 0 or 1 into our memory chips. So one type of memory is read-only memory or ROM. Okay, so I know that you know already the basic comparison of this one. Okay, so when we say read-only, so the data is already stored in that particular chips and you can no longer add additional information on that memory chips. Okay, when we talk about random access memory is what they call the temporary working storage for data and programs. Okay, so we said temporary, that's what we call volatile memory. When the power is off, all of the informations or all of the stored information towards to that chips will automatically be erased. That's why it's called temporary working storage. Okay, adding more RAM in our computer enhance the performance of our computer system. So however, maximum amount of RAM that can be installed is limited in terms of the motherboard. So because we need to check how many RAM slot, physical RAM slot you might be having, or how many capacity of the static RAM you will be having. So later we will be showing to you what are the static random access memory and what is the dynamic random memory. Okay, so let's go with the ROM first. So these are the different types of ROM. Okay, so it starts with the read-only memory. Okay, and we have the PROM, or P stands for programmable read-only memory chips. Then we do have the EPROM, or what they call the erasable programmable read-only memory. Okay, and then we have the EEPROM. The EEPROM is what they call the electrically erasable programmable chips, and how they differ from one another. Okay, so the read-only memory chips, once we write the information inside with this particular chips, then that's it. You can no longer add any more data, okay, um, in it. And mostly, you will not be able to have the chance to erase or rewrite, okay, on that particular chips anymore. It goes differently in terms of programmable ROM. Programmable read-only memory chips is written after it is manufactured. Okay? So PROM are manufactured blank, then you're going to add the informations or the program, okay? Then generally this particular chip also cannot be erased, and it can only be programmed once. So that's what we call the programmable read-only memory. So the EPROM, or the erasable, one reason why it calls erasable, okay? So that particular erasable can be rewritten again, okay? Provided that you need to erase first the program inside and then reprogram again these particular chips, okay? So how you going to do that one? So if you will see this tiny, okay, part here, so you just need to expose this one to the ultraviolet light. So you just expose it. So you will see some of this particular chip that it has sticker, heavy sticker, or somewhat gray sticker, okay? Then when you remove that one and expose it to sunlight or ultraviolet light, then all of the data will be erased, and then that's a time you can again reprogram it, okay? Then we have the EEPROM, or electrically erasable, okay, programmable. So the same with this one, the concept, but how you going to erase, okay, using electricity, okay? So using electricity, so you will supply a certain voltage level on the EEPROM, okay, so that your chips will be rewritten, or again can be reprogrammed.